Okay, hello, it's Alphonse, and today is the 24th day of the LeetCode 30-day challenge. And sorry for the late video because I am out of the town to eat with my family and friends. Okay, so today is LRU Cache. So basically the problem is we are implementing a LRU Cache where the we must implement the get function where returns of the key if exists in the cache, get the value of the key, otherwise returns -1. And second is get put the key and its corresponding value into the cache. So for example, the cache now contains 1, 1, 2, 2, and get1 returns 1. And put 3, 3. Here's the top of cache down. LRU cache size is 2 because we get 1, 1 first, so 1, 1 will be moved at the top. And then we want to put 3, 3 into the cache, but cache is now full, so we remove the least recently used, which is 2, 2. So it has been removed and then clear. So 1, 1 will drop to a lower level, and then 3, 3 will be put into the cache. And then get 2. Here is talking about the example in the problem description. Returns -1. And put 4, 4 because now 1, 1 is the least recently used, so it will be pop out. And 3, 3 decrease the priority. So 4, 4 is now in, and we get 1. So we return -1. And then get 3 returns 3, get 4 returns 4. Okay, so because the problem wants we to use get and put in all once time complexity, so basically we will use the data structure that is based on linked list, because we want to modify the head and the tail to be the linked list is a pair of key value, and this is the head and tail, where the more the more the the higher priority it is, then it should be at closer to the head. So now recently used will be higher and low. So I think we will insert the key value pair like this, KV, KV, and KV. And on the other hand, we should use unordered map, which is a hash map on order to store the key and the corresponding list iterator. Why? Because when we access the element in it, say like in the middle part, when we access it, then it will instantaneously become the it will instantly become the most recently used object. So we must get the list operator that we can use list splice to move the object using the iterator in O1 time, because the modify a pointer in linked list for a single object or two objects, because the size is fixed, then the time complexity is only the constant. Okay, so how do we solve this problem using these two? For example, in the query of the problem example, like put get put get put get put get put get and get. So we put 11 kv put 22 get 1 put 33 get 2 put 44 get 1 3 4. So we do this step by step. Okay, so we initialize the m, the order map m, and the linked list LRU cache here. Okay, so here we go. We put 1. This is the tail of the head, and this is the head, which is the recently used, and this is the least recently used. So 1 at here. So the value, the key 1 actually hash 2, or its value is the iterator here, and then put 2 in front of the 1. So we use in place front or something like that. insert from in place from in the C++ standard library. 1 1 2 2 and get 1. So 2 have the iterator here, and then we get 1. Since 1 1 is used most recently, then it should be moved to the front, which is the function that cache.splice cache.begin cache is the subject, and mKey is the iterator of it. So we put this iterator to the first object of the cache, which is what we are doing now. It's this one. Okay, and then put 3 3, but 3 3 there is no space for 3 3, so we simply remove this and this, and now the cache become 1 1 3 3, and here with key 1 and 3, which points to their iterator. Okay, and then we get 2, but nothing in 2, so it will return -1. Okay, and then with let's see the -1 and put 4 4. 1 1 is the least recently used now, so 1 1 will be removed, and then put 4 4 in front of it. 4 4 and 3 is removed since sorry, 2 is removed. Sorry, 1 is removed. I'm so tired now. 1 is removed. So there are only 3 and 4 in this now at here, this stage. Here we are at this step, and 3 and 4 map to their own respective iterator. And then we just get 1 because 1 is not in it, so it is -1. And get 3, return 3, get 4, return 4, and this is our overall procedure. Okay, so let's see how to implement in code. Here. So we have the total type of LRU cache. Oops, something is wrong with my Bluetooth keyboard. Okay, so now we initialize the max capacity. and the unordered map for the mapping the iterator here, which is this structure, this one. Okay. This pair of int in m, and the list pair int cache. Maybe just use cache. So max capacity equals to capacity, and get the key, because we first must find whether the key exists in the cache. So auto found m.find key, and if found m.end, which means does not exist in the cache, then return -1. And then if it exists, then update the current touched object to front. So cache dot splice cache that begin, and the overall structure is cache. And what thing we want the m key, which is the pair to the front. So return m key second, or simply se. So what do we do for put? So still auto found f equals to m.find key, and if does not exist, then if exists in if element, then we simply in cache already, then simply update the value. So we found and update to the cache, because we touch this element, so we must put this element still to the cache the begin. And if not, then if cache.size equals to max capacity, then we must select the recently used. Swap out. So we find out what to delete. So int to delete. The value is to delete is cache dot back dot first, and we want to remove it from the order map or hash map as well. So m.find to delete and cache dot pop back. Okay, and then insert at front because this is the newest element, KB. Key equals to cache begin update the iterator. Okay, let's see if this works. Okay, I forgot this one. So tired now. Okay, it's time for sleep. I'm very tired now because I wake up at 7 a.m. and now it's nearly 2 a.m. So and near to I have the nap time. So thank you for watching and see you tomorrow.